Most of us are meteorologist types by trade. We got into the space weather business either through a stint with the Air Force, which most of us are retired Air Force in here, which I managed to get the space weather on that end. Then we got hired on here. We study the sun with some of the images you see up on the displays in here already, but we really closely examine sunspots, trends, magnetic fields, intensity, shear developing in there, and so on to get a flavor for, is this sunspotted region or this active region going to produce a solar flare? And if so, how strong might it be, and what's the odds that that might happen? So when the solar flare happens, it's a speed of light thing. We observe it, we see it, the effect is already here on the sunlit side of our planet. So we can't warn on that. I mean, it's already happening. We can alert, and we will alert on that solar flare when it hits R2 criteria, and then we'll summarize it with what level we hit. So we can't warn on it, and we can't put watches out for it. But when we come to forecasting these events, we forecast the probability that they might happen. So we're very probability-based forecasts in here. We don't have a good spacecraft out there to tell us that these are coming. Discover's out there now, the replacement for ACE, ACE being research, Discover being our NOAA bird, but there's not a sensor on there to tell us if there's high-speed energetic protons coming at us or not. So we don't have that buoy anymore with Discover. It's not till it hits go, is what you saw hanging up in the foyer, that we actually know that they're already here, and now we got to decide how quick they might be rising. And a lot of these times, these come like a snowplow. They're just there. It'll be steady. It won't be a sudden buildup. It'll be wham. We're just hit. The radio blackouts happen because the ionosphere gets suddenly heated up from the solar flare. Thus, it inhibits the normal refraction and reflection of these radio waves to happen. Very important to aircraft and air traffic control. You can imagine flying across the Pacific Ocean and the Atlantic Ocean, huge swaths of the water, thousands and thousands of miles. That is the main way they communicate. It's a little expensive to talk to a satellite, and there's no floating cell phone towers out in the middle of the ocean, so HF radio is the main means. And when they're flying across the poles, like the North Pole, to shorten distances, that is the way they communicate. So when we have certain probabilities that that might happen, they may have to plan ahead and change their routes a little bit. But generally it's more of an awareness thing, and they'll risk it and go anyways, and then just deal with it as it happens for those events. Radiation storms, we do something very